All right, guys, so this is going to be how we do your notes from now on. This should hopefully be a little bit easier than you guys just following along past or through our Google Classroom notes. I will still post these notes on Google Classroom, but at least this way you've got the written version plus me talking that'll hopefully make things a little bit easier. I'm going to go over 7.1, 7.2, even though you've already done them, because you guys are going to have a retest. So we're going to start with 7.1, which is the sine law. One of the first things you guys should have done when you looked this over was sine, cosine, tan. So the trigonometric ratios. Sine, cosine, tan, one of the most important things about them is you can only use them for a right triangle. Okay, so these things are only for right triangles. If your triangle does not have this little symbol right here, it is not a right triangle. You can't use these formulas. This is the only time. Okay? When you're doing these, we talked about the opposite side, we talked about the adjacent, we talked about the hypotenuse. The hypotenuse is always the easy one to find. So the hypotenuse, if you turn your right angle into an arrow, it points at the hypotenuse. The opposite and the adjacent are a little bit different. They aren't always set. So if you have your right triangle, your right angle's here, this is going to be your hypotenuse. If this is the angle you're looking at or know something about, the side straight across from it is always your opposite side, which means your third one is the adjacent. Adjacent means right beside or touching, so it's the other side that's touching that angle. If we have the same triangle, and this is the angle we're looking for, this still points at our hypotenuse, but now the side straight across from that angle is the opposite side, and the third one is the adjacent. Okay, so hypotenuse is always set. It's always the one across from the right angle. The opposite adjacent depend on the angle you're looking at. So if we're working with those simple trig functions, very first thing you ever want to do with these triangles is always identify your sides. So we start with your hypotenuse, always. This is the angle we know, which makes this the opposite, which makes this side the adjacent. Once you've labeled your sides, you need to pick a trig function that has the two sides that you know something about. So in this case, picking a function that has the hypotenuse doesn't actually help me with anything. I don't know anything about the hypotenuse, and I'm not trying to solve for it. So in this case, I need a trig function that has the opposite and the adjacent, and that's going to be the tan formula. So tan of our angle equals opposite over adjacent. So always start by writing your formula, and then fill in what you actually know in the question. So I know that tan, my angle is 67 degrees. My opposite side is the 204.9. And my adjacent side is the x. It's the thing I don't know, the thing I'm trying to solve for. Anytime the thing you're solving for is on the bottom of that fraction, the easiest way to rearrange and get it by itself is to just switch everything on the left-hand side of the equal side with everything underneath. So when I swap these two, I end up with the x by itself, the 204.9 stays exactly where it is, and the tan 67 is on the bottom now. Then all you have to do is put this in your calculator, and you're type it in exactly the way it's written. 204.9 divided by tan and then 67. One thing you need to make sure you check before you use any of the trig functions in your calculator is that your calculator is in degree mode. If it's in radian mode, all of your answers are going to be wrong. So double check your calculator is in degrees. When you do this one and you're working with degrees, you should get an answer of 87.0 centimeters. Okay, this is exactly the same as what it says down here in the solution. The solution just shows you the longer version of rearranging. So it's the exact same to here. And then if you actually want to multiply and move things around, you would multiply both sides by x to get rid of this x down here. And then you'd have to divide by 67 to get the, divide by tan of 67 to get the tan of 67 off. And then that rearranges it. This right here, though, is the exact same thing as what I did when I just swapped the two sides. Okay, same steps. If you like the rearranging, do it this way. If you like the just swapping, do it the other way. Either way, make sure you're getting the same answer every time. Okay, part B is the second triangle. If we label that second triangle, the side across from the right angle is the hypotenuse. The side across from the angle that we're looking at is the opposite, which makes the third side the adjacent. In this case, we have hypotenuse and adjacent. So we want to use a formula that has hypotenuse and adjacent in it, which is our cos formula. And so that's what they do down here. Oops, sorry. So down here, we're using our cos formula, adjacent over hypotenuse, filling in our adjacent number over our hypotenuse number. When you go to solve this in your calculator, you got cos of x equals 15.2 over 17.8. And to get the x all alone, we have to do the opposite of the cos function, and that's the inverse cos, or the cos -1. And when we do it on this side, we also have to do it on this side. And what that does is the cos -1 and the cos cancel and just leave the x all by itself. But we've now got the inverse cos of the 15.2 over the 17.8. Okay, so you're gonna, to get the inverse cos function on your calculator, you're gonna do second cos, and then you'll type in your 15.2 divided by 17.8. And that'll give you a value of your degrees. So we should get approximately 31 degrees. Okay, so exact same process every single time when we're working with right angles. So always start by labeling your triangle. So hypotenuse, opposite, adjacent. In this case, the two sides we're to know something about we're working with are the hypotenuse and the opposite. If we're using SOHCAHTOA, opposite and hypotenuse is going to be our sine function. So sine of our angle is the opposite over the hypotenuse. Fill in what we know. So we know our angle. We know our hypotenuse is 9.4. We know our opposite goes on top. So our x goes on top, and our hypotenuse is 9.4. When the x is on the top of the fraction, we rearrange it slightly differently. We can't just swap sides. This is saying x divided by 9.4. So we're going to do the opposite. We're going to multiply by 9.4 on both sides, so that the 9.4's cancel out. What that leaves us with is x equals 9.4 times sine of 28. And actually, I'm not going to put those in there, because in your calculator, you're going to do 9.4 sine, and then the brackets are actually going to go right there on your calculator. But if you do 9.4 times sine 28, you can do it all in one step in your calculator, and it's going to tell you that x is approximately 4.4. Because we're given units on the triangle in the question, we need units in our answer. So it was 9.4 centimeters for the hypotenuse, which makes our answer 4.4 centimeters. For the next one, always start the same way. Label our triangle. So across from the right angle is the hypotenuse. Across from the angle we know something about is the opposite. The third side is always the adjacent. In this case, the sides we're working with are the adjacent and the opposite. The formula that has opposite and adjacent in it is tan. So tan of our angle is the opposite over the adjacent. Fill in what we know. Tan of 32 degrees. Opposite is 43.6. Adjacent is our x. When the x is on the bottom, we swap the two sides. So x equals 43.6 divided by tan of 32, which means x equals 69.8. And then because we had units, we need units. It was centimeters originally. This is centimeters. Third triangle, exact same steps. Start by labeling our sides. Across from the right angle is the hypotenuse. Across from the angle we know is the opposite. The third side is the adjacent. So in this case, we're using the hypotenuse and the adjacent. A and H is the cos formula. So cos of our angle is the adjacent divided by the hypotenuse. So cos of 42 equals x over 16.5. The x that we're solving for is on the top of our fraction, which means we're going to multiply both sides by the bottom. So times 16.5 times 16.5. X equals 16.5 cos 42. And in this case, x is going to be 12.3. Original units were centimeters. This is also centimeters. Okay, so this is the basics of finding a side of a right triangle. You guys should be familiar with this. You definitely did it in grade 11. You probably did it in grade 10. You probably did it in grade 9. You've been doing it for a long time. If I'm going too fast, make sure you're stopping, make sure you're pausing the video, make sure you're copying this stuff down. Work your way through it on your own if you can. Work ahead if you want, and then play the video, check that what you're doing is what I did. Make sure you're actively learning this stuff. Don't just copy it down and ignore it. Okay, next question, exact same thing. Right triangle, which means I can use my SOHCAHTOA or my trigonometric functions. Across from the right angle is the hypotenuse. Straight across from the angle that we know something about is the opposite. Third side's the adjacent. In this case, we're looking at the hypotenuse and the opposite, which is the sine function. So sine of our angle is the opposite over the hypotenuse. So sine of 52 equals 129.3 over x. X is on the bottom. We're going to rearrange by swapping. X equals 129.3 divided by sine of 52. When you type this one into your calculator, you get x equals 164.1. And because originally we had meters in our question, this is meters in our answer. Okay, so that's the process for solving these things for a side length. We can also use our trigonometric functions to solve for an angle. That's what the next couple triangles do. Okay, so it says calculate the size of angle x. So first thing you want to do is find where X is on our triangle. X is up in this top right-hand corner, which means this is the angle we're solving for. We need to know that because we have to be able to label our triangle again. We've got a right angle, which means we can use our trigonometric functions. Straight across from that right angle is the hypotenuse. Straight across from the angle we're solving for is the opposite. Third side is the adjacent. So now in this case, the two sides we've got numbers for are the hypotenuse and the adjacent. We need a formula with adjacent and hypotenuse in it, and that's our cos formula. So cos of our angle is adjacent over hypotenuse. Fill in what we know. So we don't know the angle, we have to leave it as our angle. We do know the adjacent though is 18.4. The hypotenuse is 24.5. And now to get the angle all by itself, we do the inverse. So that our angle, these cancel, is the inverse cos of 18.4 over 24.5. And again, you're doing second cos to get the cos -1 on your calculator. When you work this one out, your angle works out to be approximately 41 degrees. Make sure you include the degrees sign because you're talking about an angle. In all of these cases, we're looking for angle X. So this angle on this triangle, start by labeling your sides. Straight across from the right angle is the hypotenuse. Straight across from the angle we're solving for is the opposite. The third side is the adjacent. So the formula we need this time has to have opposite and adjacent in it. O and A is the tan formula. Fill in what we know and solve. So we don't know our angle, but we do know the opposite side is 3.8. We do know the adjacent side is 4.5. We're going to do the inverse to get rid of it, so tan -1 on both sides. Makes this cancel. So the inverse tan of 3.8 divided by 4.5. And our angle equals 40 degrees. Degrees because we're talking about an angle. Last one. So angle X is this bottom angle down here. Label our sides. Straight across from the right angle is the hypotenuse. Straight across from the angle we're looking for is the opposite. Third side is the adjacent. Now we need something with hypotenuse and opposite in it. O and H is the sine formula. So sine of our angle is the opposite over the hypotenuse. Fill in what we know. And then solve. So inverse sine, cancels the sine symbol out. So you're going to do second sine, and then in your brackets, 15 divided by 22. When you do that, you get an angle of 43 degrees. Okay, one more on the next page. Angle X is this one over here. Label our sides. Straight across from the right angle is the hypotenuse. Straight across from the angle we're looking for is the opposite. Third side's the adjacent. So we need a formula with opposite and adjacent in it. Oh, and A is the tan formula. Fill in what we know. And then solve. So we want the angle by itself, so we're going to get rid of the tan by doing the inverse tan, or tan -1. Our angle equals inverse tan of 124.6 divided by 112.4. So our angle is going to be 48 degrees. Okay, that's right triangles. These formulas only work for right triangles. The problem is pretty much none of the triangles in this section are right triangles. That's why we need to learn the sine and then the cosine law. We're starting with the sine law. Okay, so this part of the notes say using the trigonometric ratios of sine, cosine, and tangent, as well as the Pythagorean theorem, you can solve for missing side lengths or angles of right triangles. But what happens if you want to know a missing measurement from an oblique triangle, a triangle without a right angle? The sine law can be used to solve for an unknown side length or an unknown angle measure of an oblique triangle in certain situations. The sine law states that for a triangle ABC, sine of A over side A equals sine of B over side B equals sine of C over side C. Okay, so we always use capital letters to describe our angles, lowercase letters to describe our sides, and they're always paired up. So capital A and side, and so capital A, which is angle A, and side A are always straight across from each other. Angle B, side B are across from each other. Angle C, side C are across from each other. We can use the sine law if we know two sides and the angle opposite one of them. This would allow you to solve for the angle opposite the other known side. So basically, we have to have an angle and a side pair where we know both things, and an angle and a side pair where we know one of the two. So two sides and the angle opposite one of them, or two angles and the side opposite one of them. These are the only two cases where we can use our sine law. Okay, so sine law is different than the sine function. Sine law is for angles that don't, or triangles that don't have a right angle. Actually, sorry, I'm going to go back to this page for a second. When you write the sine A over A, sine B over B, sine C over C like this is actually not the most helpful way to write this formula. We only ever work with it in using two of the three sets of sides and angles. So really, it's easier if we don't write it all three like that in a row. And we can flip our fractions in order to not have to rearrange quite so much. So if we want to use the sine law to solve for an angle, we're going to write it the way it's written right now, only we're just going to use two pairs because we only ever use two pairs. So it would be sine A over A equals sine B over B. If we want to solve for a side length, we're going to write it the other way. It's going to be side A over sine of angle A equals lowercase b, or side B, over sine of angle B. It doesn't seem like a big difference, but it saves you so much time with rearranging. If you're solving for an angle, make sure the angles are on the top of your fractions. If you're solving for a side, make sure the sides are on the top of your fractions. It just makes things way easier. Okay? And we only ever use two at a time, so we're just going to write the two fractions. So to use this, it says use the sine law to calculate the length of side A. To know if we can use the sine law or not, we first have to check if this is a right triangle. It obviously isn't. The only time it's going to be a right triangle is if it has that little right triangle box in one of the angles. This is not. So what we have to look for is sides and angles that are across from each other that are paired up. And in this case, we do have a pair. We know the 52, and we know that the side across from it is 16.8. We're looking for side A, which means we have to have the angle across from side A as well. And in this case, we do. We've got the 72 degrees. So in order to solve for this, we're going to, because we're solving for a side, and because we have a pair where we know both parts, the 52 and the 16.8, and a pair where we know one of the parts, we can use our sine law. We're going to rewrite it though. We're solving for a side. We want side A. So we're going to write our sine law with the side on top. So A over sine A equals B over sine B. In this case, our triangle is actually labeled A, B, and C, and it matches up with what we're trying to do. If it didn't, it wouldn't matter. I would still put A and B in my formula, and then I would just fill in with what I know. So I like to leave the side that I'm solving for as part of my first fraction. So A is going to stay A. The angle that goes into the sine on the bottom is the angle directly across from the side I'm solving for. So the angle across from it is this top one, the 72 degrees. So the 72 degrees goes in at the bottom. And then it has to equal the side angle pair where I know both the side and the angle. So the side that I know is 16.8, so the 16.8 goes on the top. And then the angle I know is the 52. So sine of 52 degrees on the bottom. Then I just have to rearrange and solve. To get this A, lowercase a, side A, on the top by itself, I have to get rid of the divide by sine of 72. And to get rid of a divide by sine of 72, I do the opposite. I times sine of 72. And if I do it to one side, I have to do it to the other side. When I have a times sine 72 and a divide sine 72, they cancel out. And it just leaves A on this side. On the other side, that times sine of 72 goes on the top. So I've got 16.8 times sine of 72 divided by sine of 52. Most calculators won't care, but you might need to put, or if your calculator automatically puts a bracket right here, make sure you put a bracket on the other side of the 72 before you do your divide sign. Otherwise, you should be able to do this all in one step. You just do 16.8 times sine, if it puts the bracket in, 72, close your bracket, then divide by sine of, and then again, it'll put a bracket in, 52, close your bracket. If you do that all in one step in your calculator, or if you solve the top, solve the bottom, and then divide the two numbers, it's going to give you that A equals 20.3. And because we had centimeters in our original question, this is also going to be centimeters because we were solving for a side length. Okay, so the way I do it, this was 3 steps. The way the book is showing you is like 8 or 9 steps. Okay, and this is why I find it way easier to rearrange and put your sides on top in order to solve and get, if you're solving for a side, put your sides on top. Realistically, what I did in my very first or second step, took all of these steps, and then they ended up with the same thing in the end. It's a lot more rearranging if you start by writing your side on the bottom, if you're solving for the side. So do yourself a favor, don't make yourself have to rearrange like this. Flip your formula before you even put numbers into it. Your life will be so much easier. Okay, so we'll do some practice questions. So it says calculate the length of the indicated side. In this case, the indicated side is this one over here. Z equals question mark. So in order to figure out if we can use our sine law, we have to have an angle and a side that are across from each other that we know both parts, and we have to know the angle across from Z. So the first thing I want to look for is, do I know the angle across from Z? In this case, I do. Then I need to find that other pair that I know both parts of. And in this case, it's the 132 degrees and the 1,794.3 meters. Since there's a pair where I know both parts and I know the angle across from Z, I can use my sine law to solve this. I'm solving for a side, so I'm going to write my sine law with the sides on top. So A over sine A equals B over sine B. In this case, with this diagram, the side we're solving for is called Z. So instead of an A, I'm going to put my Z on top. And then underneath it, it's going to be sine of the angle that's directly across from side Z, which was the 15 degrees. And then our other pair, because we had our side on top of our first fraction, we need our side on top of our second fraction. So the 1794.3 over sine of the angle directly across from that side. To rearrange this, I need to get rid of the divide sine 15. So I'm going to multiply by sine 15 on both sides. That's going to cause this side to cancel out and just leave me with Z. 1794.3 times sine of 15, all divided by sine of 132. If your calculator doesn't make you, don't put the brackets in. When you do this, and so long as you're in degree mode, Z should be 624.9. And we're finding a side length. It needs to have units. Our original units were meters. This is in meters. Part B, it wants a side length. Exact same steps. So to figure out if we can use the sine law, we check our side, see if we know the angle across from it, which we do, and then we need to have another pair where we know both parts. In this case, we've got that. This is my indication I can use my sine law. I'm using my sine law to solve for a side. So A over sine A equals B over sine B. The side I'm solving for in this case, they called M. So I'm going to put M into my formula. M divided by sine of the angle straight across from M, which was the 43, equals B, so the other side that I know, which is 15.9, divided by sine of the angle straight across from it. So 15.9 is straight across from the 61 degrees, so sine of 61. I'm going to rearrange to get the M by itself. I have to get rid of the divide by the sine 43 by doing the opposite, so times sine of 43 times sine of 43 makes the sine 43's cancel. M equals 15.9 times sine of 43 divided by sine of 61. And you put this all in your formula, or into your calculator, sorry. M is 12.4. And because we had centimeters in our original triangle, this is 12.4 centimeters. C is the same thing again. We're looking for a side. If we can use our sine law to solve for this side, we have to know the angle across from it. When I look at the angle across from it, there's no number. I do have a pair where I know both pieces. I've got the 40 degrees and the 36.3 centimeters for a side length. So I do have one complete fraction, one pair of side angle that I can use. If I try and do this with the 34 degrees over here, I'm not going to solve for side P. I'll end up solving for this side over here, and that's not what the question wants. So I can't use the 34 degrees and then get side P. It has to be angle P, straight across from side P. So I need this angle. And there's a trick to finding this angle. I know that triangles, the angles in a triangle add up to 180 degrees. So if I know two of the angles in my triangle, I can find the third one by taking my total 180 degrees and subtracting the two angles that I already know on my triangle. So in this case, it's going to be 180 minus 40 minus 34. If I do that, I end up with 106 degrees. That means that this angle right here is 106 degrees because all three of my angles have to add up to 180. So 40 plus 34 plus 106 would be 180 degrees. Now that I know that angle, I can use my sine law because I've got a pair where I know both pieces and I've got a pair where I know the angle that's across from the side I'm trying to solve for. So I'm going to use my sine law. I'm solving for a side. I'm going to put my side on top. So A over sine A equals B over sine B. In this case, the side we're solving for is called P. So P over sine of the angle that's directly across from that side, so sine of 106, equals the other side that I know, so the 36.3, divided by sine of the angle directly across from that one, which is the 40 degrees. Now I need to get the P by itself. I have to get rid of the divide by sine 106 by timesing by sine 106 on both sides. Makes this side cancel out, and P is 36.3 times sine 106 divided by sine of 40. When you put this in your calculator, it works out to that P equals 54.3. We had centimeters in our original question, centimeters in our answer. Okay, so next is how we use the sine law to solve for an angle. I'm not going to write out step by step because this one's actually a pretty good explanation, but we still start the same way. We need a pair where we know the angle and side across from each other, which we've got. And the side that we know, we can solve for the angle across from it as well. In this case, it wants both angle A and angle C. When we look for angle C, we don't know anything about this side. So we can't actually solve for angle C using our triangle. We have to solve for angle A first using what we know, and then worry about solving for angle C. So we can get rid of this. We can solve for A right now. So we're going to do the same thing. We're going to set up our sine law, but this time we're going to write it with the angles on top because we're solving for an angle. Again, this just makes it way easier when you're trying to solve or rearrange your formula. So angles on top, sine A over side A equals sine B over B. So A is the angle we're solving for, so we're going to leave it as sine A for now. And we're going to say sine A divided by the side that's directly across from it, so 91.6, equals sine of angle B, so the other angle we know is the 81 degrees, divided by the side that we also know, that's paired up with that 81 degrees, which is the 123.2. To rearrange, we're going to get rid of this divide by 91.6 by multiplying by 91.6 on both sides. That makes the 91.6 cancel out and just leaves our sine A. And then just like for our trig functions, to get rid of the sine A, we have to do the inverse sine. And if we do it to one side, we have to do it to the other. That makes the sine and the inverse sine cancel out. Leaves us with angle A equals the inverse sine of 91.6 times sine of 81 divided by 123.2. Our angle measurement becomes 47 degrees. For your angles, always just round to the nearest whole number. And then because now we know two of the angles in our triangle, we can find our third one. So we know that a triangle adds up to 180 degrees. And if we subtract the two angles that we know, so the 47 degrees that we just found, the 81 degrees that we were given in the question, our third angle is going to be 52 degrees. Okay, so you can't always directly solve for what they're asking you for. Sometimes you have to solve for what you can first and then see how it helps you. So in this case, this one looks fairly straightforward. It says calculate the measure of the indicated side and or angle. So you're looking for wherever the question marks are. In this case, our question mark is this angle, which means in order to be able to use our sine law, we have to know the measure of the side straight across from it. So when I look at the side straight across from it, I have a number there. That's step one to be able to use my sine law. The second thing I need is that angle side pair, where I know both pieces, and in this case I have that as well. So I can use my sine law to solve for that angle. So we're going to write our sine law with the angle on the top. So sine of A over side A equals sine B over B. In this case, it is actually called angle A, the one we're looking for. So we're going to say sine A divided by the side that's directly across from it, which is the 45.1, equals sine of the other angle that we know, so sine of 121, divided by the side directly across from the 121 degrees, which is the 77.5. To rearrange, we have to multiply by the bottom, so times 45.1 times 45.1 makes that cancel out. Sine A equals 45.1 sine of 121 divided by 77.5. I like to put the number in front of the sine 121, the number that I'm multiplying by, and the reason why is sometimes your calculator will do weird things if you put it after the 121. If you did sine of 121 and needed a bracket and forgot to put it in and then did your times 45.1, it would do 121 times 45.1 and then take the sine of that, and that's not what you're trying to tell it to do. So just to be safe, write that number out in front, and then it doesn't matter so much the order that you put things in your calculator. To solve for our angle, we still have to get rid of this sine piece over here, so we need to do the inverse. That makes it cancel out. So angle A equals the inverse sine, or sine -1, of 45.1 sine 121 divided by 77.5. When you put this in your calculator, you're going to do second sine, a big bracket, type it all in. It should give you, in this case, 30 degrees. If it doesn't, double check with Ms. Cost and make sure you're putting things in your calculator right. Same thing here. In this case, it wants the angle. That's where our question mark is. In order to use the sine law, we have to know the side directly across from that angle, which we do, and we have to have a pair where we know both pieces, which we've got. So we can use our sine law to solve for this angle. We're going to write it with the angles on top. So sine A over A equals sine B over B. So we're solving for our angle, which in this case we're calling H. So sine of H over the side straight across from it, so the 12.7, equals sine of the other angle we know, which is the 52, divided by the side that's directly across from it, which is the 16.4. Now we rearrange, we times by the 12.7, which cancels, leaves sine H equals 12.7 times sine of 52 over 16.4. Inverse sine gets rid of the sine on this side. So that cancels. H equals inverse sine of 12.7 times sine of 52 divided by 16.4. And so capital H, our angle H, equals 38. And because it's an angle, it's degrees. This time we've got two pieces. This triangle wants this angle N, and it also wants side M. Using our sine law, the only way to solve for side M is to have angle M. We don't know anything about angle M yet, so we can't start there. When I look at angle N, I do know the side across from it. And because I have a pair where I know both pieces, I can solve for angle N first, and then use that to help me with the M's. So this piece is going to wait. So I'm going to start with N because I know part of N. I know the 6.5. I know the side across from it. So I'm using my sine law because there's a pair where I know both pieces and a pair where I know one. I'm solving for an angle. I want the angle on top. Sine A over A equals sine B over B. In this case, my angle is called N, so sine of N over the side across from it, which is 6.5, equals sine of the other angle I know, which is the 81, divided by the side directly across from it, which is the 15.3, times by the 6.5, and then inverse sine to get our angle. So you're going to do inverse sine of 6.5 times sine 81 divided by 15.3. And N is going to be 25 degrees. Even though N and M are not connected, this 25 degrees helps us. Because if I know that this right here is 25 degrees, I know two of the three angles in my triangle. That means I can calculate angle M. Because I know my triangle should be 180 degrees. If I subtract the two that I know, it's going to tell me what angle M is. So 180 minus 81 minus 25, 74 degrees. I'm going to write this in here. Because now that I know this 74 degrees, I can solve for angle M, or side M, because now I have this pair where I know one piece, I know the angle, I can use it to find the side across from it. To do this, I'm going to use my sine law again, and I'm going to use the pair that I know, and then the m's. So, but because I'm solving for a side, I want to write it with the sides on top. So a over sine A equals b over sine b. I also know the n pairs now. I know that n is 25 degrees and the side across from it is 6.5. When you're solving these, it's best to go back to the original information you're given in the triangle if you can, just in case you made a mistake. You don't want to use a wrong answer to get another wrong answer. So it's always safest to go back to the original information you were given if you can. Okay, so I'm going to go back to my 81 degrees and my 15.3 to be the pair where I know both sides. So the side I'm solving for is m. So I'm going to say m over sine of the angle directly across from it, which is 74, equals this other side that I know, 15.3, divided by sine of the angle directly across from 15.3, which is the 81. And I'm going to multiply to get the m by itself. So I'm going to multiply by this bottom, the sine 74, on both sides. So those sine 74s cancel. It leaves me just with m equals 15.3 times sine of 74 divided by sine of 81. When I type all of that into my calculator, m is 14.9, which needs to have units. And my original units in my question was centimeters. This is also centimeters. Okay, so if it asks you for more than one thing, chances are you're using your formula more than one time. The next thing that the workbook does is it gives you word problems. Triangles are never just triangles. They try and put them into real world contexts. So this one says, Miguel is an arborist and he needs to calculate the height of a tree that he'll be removing from a construction site. The tree is leaning at an angle of 85 degrees with the ground. Miguel stands 30 meters from the base of the tree and calculates the angle of elevation to the top of the tree to be 32 degrees. What's the height of the tree? So if that was all it had given you, the first thing you would need to do would be to draw a diagram. So you draw a little tree, it's leaning at an angle, and we know that angle that it's leaning at is 85 degrees. This is not a right-angled triangle because it's not perfectly straight up and down. We can't use SOHCAHTOA. We know that Miguel is standing 30 meters away from the tree. So here's little Miguel. He's 30 meters away. And when he looks up to the top of the tree, the angle of elevation from the ground up to his line of sight to the top of the tree is 32 degrees. We're trying to find how tall the tree is. So we want to know this side over here. And in order to use our sine law, we have to have a pair where we know both the angle and the side opposite to it. Right now, I know my angle across from the side that I'm trying to find, but the angle across from the 30 degrees, or across from the 30 meters, is this one up top. So in order to be able to use my sine law, I have to know that top angle. Luckily, I know two of the three angles in my triangle, which means this angle is going to be 180 degrees minus the two angles that I know. 180 minus 85 minus 32 is 63. So this up here, 63 degrees, which now means I have a pair where I know the side and the angle, which means I can use the sine law. That's what they do down here, only they do it the stupid way of rearranging, so it goes on to the next page. Should have just written it with the sides on top to start with. If you had done that, it would have been 3 steps and you still would have got 17.8 meters for the height of the tree. The tree is approximately 17.8 meters tall. Okay, this question is very, very similar. It says a communications tower is stabilized with guy wires. One wire is 3.7 meters long. A second guy wire is attached to the pole 1.25 meters higher than the first wire from the same anchor point on the ground. The angle made between the 2 wires is 10 degrees. What's the length of the second wire? Okay, so we need to figure out where we can start, what we can actually work with here. We can't just assume that this is a right angle and use our right triangle formulas, because there's no guarantee that this tower is standing perfectly straight. It doesn't say so in the question, we can't assume it. What we do know is the things that are drawn onto the picture. And right now, it looks like that weird little triangle is going to help me the most. I have to think of this as 2 or possibly 3 different triangles. There's a little triangle here, or I can work with the slightly bigger triangle right here, or I can work with the big outside triangle. Depending on what I have enough information for. Whoops. Okay, I'm going to start with the little one. And I'm going to start with the little one because I see that I have this angle side pair. That might actually help me. I'm going to redraw that little triangle just so I see only the pieces that I'm working with. Doesn't have to be beautiful, doesn't have to be the same size, just has to be good enough that I can label some things. So this is 10 degrees, this is 1.25, and I also know that the bottom piece of this triangle right here is 3.7 meters. This is the side I'm trying to find, which would mean I would need to know this angle right here. I don't know that angle. But because I have this 3.7, I can find this top angle because that's a pair. I can do that because I have this pair that I also know. The 10 degrees and the 1.25 are directly across from each other. So I'm going to use my sine law to try and solve this. So in this case, I'm solving for an angle. I can't solve for this side yet, so I'm going to solve for this angle instead. So I'm using my sine law with an angle on the top because I'm trying to solve for an angle. So sine of A over A equals sine of B over B. So sine of my top angle divided by the side directly across from it, so divided by 3.7, equals sine of angle B. So this, the angle of the pair that I know both parts, so sine of 10 over the side directly across from it, which is the 1.25. Rearrange, solve for my angle. So I'm going to times by 3.7 times by 3.7, so this cancels. So sine of my angle equals 3.7 times sine of 10 over 1.25. Inverse sine to get rid of my sine on this side. Got to do it to both sides though. The angle is sine -1, or inverse sine of 3.7 times sine of 10 over 1.25. Put that in my calculator. The angle is 31 degrees. This is not the answer that the question wants. This is just one step in getting me to the answer that the question wants. So I now know this top angle is 31 degrees. That helps me because I need this angle right here, and now I have 2 of the 3 angles in my triangle. So this angle is going to be 180 degrees minus the 2 angles that I know. So 180 minus 10 minus 31 is going to be 139. And now I can solve for the side that I want. So I'm going to just redraw this triangle one more time. This is my 139. This is the side I'm solving for. So my pair, where I know both pieces, and my pair where I only know one piece. This time I'm solving for a side. I want side x. So I need to write my formula with the sides on top. So a over sine A equals b over sine b. The side I'm solving for is called x in the one I drew, divided by sine of the angle directly across from it, so 139. Side B is the side that I know the pieces of, so the 1.25, divided by this angle that's directly across from it, which is the sine of 10. When times by sine of 139, to get my x by itself, makes this cancel out. X equals 1.25 times sine of 139 divided by sine of 10. So if I work it all out, x equals 4.7. I go back to my original diagram to see what my units were. It was measured in meters, 4.7 meters. Okay. Often the more complicated or the word problems are going to be more than one step. So don't expect that you're always going to get your answer with just one time or one use of your formula. It's often going to be 2 steps. The next one, not a great diagram, but luckily you guys have the diagram in your workbook. Says Kat and Steve are hiking in Bugaboo Provincial Park in BC. In Silver Basin Meadow, they follow a creek. They are 20 meters apart on one side of the creek when they spot a pika, a small mammal, on the opposite side of the creek. So how far is Kat from the pika? I'm just going to redraw the whole diagram just because it's awful. Kat's down here. Pika's there. Steve is here. I know that they're 20 meters apart. So from here to there is 20 meters. And I'm told in the question that this is 17 degrees and 36 degrees. So it wants to know how far is Kat from the pika. This has a right angle triangle symbol. So if the Steve half of the triangle is a right triangle, that also means the cat half of the triangle is a right triangle, which means I can go back to using my easy formulas if I can. If I look at just the cat part of that triangle, I know that this is 17 degrees. I know that this is what I want to solve for. How far is she from it? But I don't know either of these sides. The 20 meters is for the entire length of it, and I don't know how much is on the cat side and how much is on the Steve side. So that being a right triangle doesn't actually help me. I need to look at this as if it's a one big triangle. So if I look at it as if it's one big triangle, this is where the pica line is. I'm going to pretend that I can take that line out. So cat side is K, this is the pica, this is Steve, this is 17 degrees, this is the side I want to find. The bottom, the entire bottom is 20 meters, and this is 36 degrees. I can use my sine law if I'm lucky, because this side and this angle are directly across from each other. If I have another side angle pair where I know both parts, I can use my sine law. I don't know anything about this side over here, the side across from the 17 degrees, but I can find this angle so that it's across from the 20 meters, because this top angle is going to be 180 degrees minus the two angles I know. So 180 minus 17 minus 36, it's going to be 127 degrees. So if this is 127, I can use that pair that I know both parts of to find the side across from the 36-degree angle. I'm using my sine law to solve for a side. So I need A over sine A equals B over sine B. So x over sine of 36 equals 20 over sine of 127. Times by sine 36 to get the x by itself. I'm going to put it over here. So x is going to be 14.7. Originally I had meters in the question, so 14.7 meters. Cat is 14.7 meters away from the pica. The next part says how far is Steve from the pica? The Steve side of my triangle is this side. So I know my 20 meters. I know my 127 degrees because I already solved for it, so that's going to be my pair I know. And the angle across from the Steve side is going to be that 17 degrees from my original. So I'm going to do the exact same thing. I'm going to call this side x. And I'm going to do the exact same thing to solve for Steve's side of the triangle. So I'm solving for a side. I'm going to write my formula for a side on top. Steve's side is x over the angle directly across from it, so sine 17 equals 20 over sine of the angle across from it, so 127, times by the sine 17 to get it gone on both sides. X equals 20 times sine 17 divided by sine of 127. And if we work this one out in your calculators, x is 7.3. Meters in the question, meters in the answer. The last part wants to know how wide is the creek. So I'm going to draw our triangle one more time. We know that this is 20 meters. This is Kat, Pika, Steve. Now though, we know that this is 7.3 meters and Kat is 14.7 meters away. How wide is the creek means we want this piece right here. Now we can use our right triangle because either half of this is a right triangle. We know this angle is 17 degrees. We know this angle is 36 degrees. Whether I pick this triangle to do SOHCAHTOA with, I know my 36 degrees, my 7.3, I can solve for this piece. Or if I use this triangle over here, same deal. I know my 17 degrees, I know my 14.7, I can use SOHCAHTOA to solve for that middle one. It's going to give me the same answer either way. It really doesn't matter. We can't use the 20 doesn't help us because the 20 again is for all the way from Kat to Steve. We don't know how much of that is on either side. I'm going to do the 17 and the 14.7 side. So the triangle I'm using is 17 degrees, 14.7. This is the side I want to solve for. Start by labeling the sides of my triangle. Right angle points at the hypotenuse. Angle that I know points at the opposite side, which makes the third side the adjacent. In this case, I'm looking for a formula that uses hyp and op. That's the sine formula. Sine of my angle equals opposite over hypotenuse. Fill in what I know. So sine 17 equals opposite, which is x, over the hypotenuse of 14.7. The x is on the top of my fraction, which means I have to multiply by the bottom of my fraction to get it by itself. So times 14.7 times 14.7 makes that cancel out. X equals 14.7 times sine of 17. So in the end, x is 4.3. And again, this is a distance. Distance has all been in meters, 4.3 meters. Okay, so again, the diagram's not great in the scanned version I have, but this one says Alexander's camping at Lake St. George, Provincial Park in Manitoba. He's taken a rowboat out onto the lake. How far will he have to row if he travels from point A to point B to point C, then back to point A? So he's basically making a triangle. I'm going to redraw the triangle just so I can actually see what the things are. So this is B, C, A. We're told this side is 1255 meters. This is 113 degrees. And this is 27 degrees. So first thing you want to do is find angle A because we can. We know two of the three angles. So this is going to be 180 minus 27 minus 113, which is going to be 40 degrees. Then we're going to do our sine law twice. Once to find side A, so the side across from angle A. Once to find side B, the side across from angle B. Okay, so let's just do A first, I guess. This is the pair that we know. We're going to use that for both of our fractions. So we've got, we're finding a side, we want A over sine A equals B over sine B. So A over, this angle across from it was the 40 degrees we just calculated. The side that we know is the 1255 divided by the angle across from it, so sine of 113 times sine 40 times sine 40. A is 1255 sine 40 over sine 113. So A is 876.4. The 1255 was in meters, so this is also in meters. So this is one of our sides. So this side right here, 876.4 meters. The other side, the side across from B. Again, we're doing solving for a side, so A over sine A equals B over sine B. In this case, we're solving for side B, so B over sine of the angle across from it, so the 27 degrees, equals the side we know, 1255, divided by the sine of the angle across from it, the 113, times sine of 27 on both sides. Makes those cancel. Side B is 1255 times sine of 27 divided by sine of 113, which means side B equals 619 meters. So this side right here, 619 meters. Neither of those is the actual answer to the question. The question wants to know if he starts at A, travels all the way around his triangle, how far has he actually rode? So the total distance is going to be, if he starts at A to B, is 1255 meters. B to C is 876.4 meters. And then C back to A is 619 meters. So if we add all three of those up, we get 2,750.4 meters total. Okay, this next example is worked out for you. I feel like we've done enough of these. This should be fairly straightforward. Have a look through it. Make sure you read it over. Check the steps as you go. But you've got a couple more examples. So this next one says, Charlie is in a hot air balloon above Regina, Saskatchewan. His friends David and Eva are watching from the ground. David and Eva are standing 100 feet apart, and the angle between Charlie's line of sight to the two of them is 11 degrees. Eva is 505 feet from the balloon. What's the angle of elevation of David's line of sight to the balloon? Okay, they've drawn the diagram. This one's pretty straightforward as well. We're looking for the angle of elevation for David, so from the ground up to the way David is looking. This is the angle we're trying to find. If I look at my triangle, I obviously don't have a right triangle, but I do have a pair where I know both pieces, and I do know the side across from David. This is my indication. I can use my sine law. So I'm using my sine law. I'm solving for an angle. I want to write it with the angles on top. Sine A over A equals sine B over B. So sine of my unknown angle, which is the David angle, over the side across from David, which is the 505 feet, equals sine of the angle I know, which is the 11 degrees, divided by the side that's across from that 11 degrees, so the 100 feet, times by the 505 to get the sine of my angle by itself. So 505 sine 11 over 100. Inverse sine to get the angle totally alone. My angle equals the inverse sine of 505 times sine 11, all divided by 100, which is going to be 74 degrees. Okay, another pole and wire question. Flagpole stabilized using 2 guy wires. The wires are attached to the ground on opposite sides of the flagpole, 8 meters apart. So from one attachment to the all the way to the other is 8 meters. The wire on the left is 4.7 meters long. This should be meters in here. The wire on the right is 6 meters long and is attached at an angle of elevation of 36 degrees. What's the angle of elevation of the wire on the left? So we want this angle over here. If we look at this as one big triangle, we have an angle side pair where we know both pieces. And if I know the side directly across from this angle, I can solve for the angle using my sine law, and I do. So I'm going to use my sine law to solve for an angle to do part A. Okay, I'm solving for an angle. I need my angle on the top. Sine A over A equals sine B over B. So sine of my unknown angle over the side directly across from it, so 6 meters. I'm not going to put the meters in there, it gets in the way. Equals sine of the other angle that I know, so sine 36, over the side directly across from the 36, which is the 4.7 meters, times by 6 on both sides to get the 6 to cancel. Leaves us with sine of our unknown angle equals 6 times sine 36, all divided by 4.7. Inverse sine to get the angle totally alone. I'm going to go over here. So our angle equals the inverse sine of 6 times sine 36, all divided by 4.7. So our angle is 49 degrees. Okay, looking at it as if it's one big triangle, we can solve for that other angle of elevation. Last question says, how high up the flagpole are the wires attached? So if I go back to our diagram, we're looking at how high up the flagpole is attached. So I'm just going to off to the side draw this little triangle out. So flagpoles, we can safely assume that this one is a right angle. So I know that this is 36 and this is 4.7. I now know that this is 49 and this is 6. Because we can assume that this is a right triangle, we can use our right triangle formula in order to solve for this side right here. Okay, so I'm just going to draw this little black triangle on the next page. Looks like that. Because it's a right triangle, we label it, we solve. So the angles, or the side across from the right angle is always the hypotenuse. The side directly across from the angle we know is the opposite side, which makes the third one the adjacent. The opposite side is the height, so that's the one we're trying to use. So I need opposite and I need hypotenuse in my formula. O and H, opposite hypotenuse, is sine. So sine of my angle equals the opposite over the hypotenuse. So sine of 36 equals x over 6. Times by 6 to get the x all alone. X equals 6 sine 36. So 6 times sine 36 is going to be 3.5 meters. Okay, the rest is homework. The practice your new skills is your homework section. Good luck. Get it done. Make sure you ask if you've got questions.